A sculpture consists of three large cubes sitting completely one over the other without overhanging. It is placed in the veranda outside the principal's office of a school. The largest cube with side 3 meter sits flat on the ground. The other two cubes have sides 2 meter and 1 meter, respectively. If 1 tin of paint is needed to paint each square meter, find the number of tins required to paint the exposed surface of the sculpture. In this question, we need to find the total number of paint cans which need to be used to paint all the visible faces of the three cubes. Note, area of one face of a cube is equal to length into breadth. Let us consider each cube at a time. Consider the topmost cube. There are 5 faces which are visible, that is, the 4 sides and the top face of the cube. Let's first find the area of one face of the topmost cube. Given side is equal to 1 meter. Area A is equal to length into breadth is equal to 1 into 1, which gives us 1 meter squared. Hence, the paintable area of the topmost cube, AT, is equal to 5 into 1, which is equal to 5 meters squared. Now, let us consider the middle cube. In the middle cube, there are 4 faces of the cube which are completely exposed, and there is one face which is partially exposed. That is, the topmost face of the middle cube is partially exposed. Let us first find the area of one of the faces of the middle cube. Given side is equal to 2 meter. Area A is equal to length into breadth, which is equal to 2 into 2, which gives us 4 meters squared. Now, let's find the area of the partially exposed face of the middle cube. We see that the top cube lies over the middle cube. This means that the top face of the middle cube is obstructed by the top cube. So, the difference between areas of the faces of the two cubes will give us the exposed area of the top surface. The exposed area is equal to area of the top surface of the middle cube minus area of the bottom surface of the top cube, which is equal to 4 minus 1, giving us 3 meters squared. Now, we can find the total exposed area of the middle cube. Exposed area of the middle cube, AM, is equal to area of 4 sides plus exposed area of the top surface, which is equal to 4 into 4 plus 3, giving us 19 meters squared. Let us consider the bottom cube. We need to find the paintable faces of the bottom cube. In the bottom cube, there are 4 faces of the cube which are completely exposed, and there is one face which is partially exposed. That is, the topmost face of the bottom cube is partially exposed. Let's first find the area of one of the faces of the bottom cube. Given side is equal to 3 meter. Area A is equal to length into breadth, which is equal to 3 into 3, giving us 9 meters squared. Now, let's find the area of the partially exposed face of the bottom cube. We see that the middle cube lies on the bottom cube. This means that the top face of the bottom cube is obstructed by the middle cube. So, the difference between areas of the faces of the two cubes will give us the exposed area of the top surface. Exposed area is equal to area of the top surface of the bottom cube minus area of the bottom surface of the middle cube, which is equal to 9 minus 4, giving us 5 meters squared. Now, we can find the exposed area of the bottom cube. Exposed area of the bottom cube, AB, is equal to area of 4 faces plus exposed area of the top surface, is equal to 4 into 9 plus 5, is equal to 41 meters squared. Finally, the total paintable area for the entire sculpture is the sum of the individual areas of the cubes. That is, AS is equal to AT plus AM plus AB, which is equal to 5 plus 19 plus 41, which is equal to 65 meters squared. We know that to paint 1 meter squared, we need 1 can of paint. Hence, the total number of paint cans which are to be used to paint 65 meters squared is equal to 65 into 1, which is equal to 65 cans. Therefore, the number of paint cans which are to be used to paint the entire sculpture is 65.